In this video, I'm going to review the problems from the Moles Guided Practice. You should already have attempted these problems on your own. This video is to give you guidance if you are unable to correctly solve any of these problems. If you're watching this video without having attempted the problems, it'll be a waste of your time. So please go back and attempt those problems if you haven't already done so. So we're going to start with the problem that's asking us how many moles of magnesium sulfate are in 5.00 grams of magnesium sulfate. So we're being given a mass, and we're trying to find the number of moles. So if we start with our mass, and we need to convert to moles, we need to use our molar mass. In order to know the molar mass, we're going to have to figure out our formula. So you should be thinking about nomenclature. Magnesium sulfate is an ionic compound. It's a metal and a polyatomic ion. So we need to determine a formula that will allow the positive and negative charges to be equal to give us a neutral compound. Magnesium has a 2+ charge. Sulfate has a 2- charge. So there are one of each of those in magnesium sulfate. So 5.00 grams of magnesium sulfate. And we want to go from grams of magnesium sulfate to moles of magnesium sulfate. And in order to do that, we need to calculate our molar mass. To find our molar mass, we need to add up all the masses of all of the elements in our formula from the periodic table. We need 1 magnesium, 1 sulfur, and 4 oxygens. When we add those up, that gives us the mass of 1 mole of the substance. So 1 mole of magnesium sulfate is equal to 120.38 grams of magnesium sulfate. So now that we've determined our molar mass, and again, molar mass is the mass of 1 mole. So when you calculate that number, when you add up those elements, the atomic masses, that's giving you the mass of 1 mole. Then we can put that into our calculator, and you should end up with 0.0415 moles of magnesium sulfate. And in our answer, you'll notice we have 3 sig figs, just like we do in our problem. In the next problem, we're being given a number of formula units, and we're being asked to find a number of moles. Formula units on our flow chart, you'll remember, are particles. They're similar, essentially they're the same as molecules, but because it is ionic, we can't, in good conscience, call it a molecule. We call it a formula unit. So let's look at our flow chart. We've got particles or formula units of sodium chloride, and we're being asked to find moles. In order to do that, we need to use Avogadro's number from our reference table. Avogadro's number from our reference table is 6.022 times 10 to the 23rd particles per mole, which is the same as 6.022 times 10 to the 23rd formula units per mole. Our formula unit is our particle in this problem. So we're going to start with 2.50 times 10 to the 23rd formula units of sodium chloride. Na is a 1+ charge. Chloride is a 1- charge. So that's going to give us a formula of NaCl. Hopefully you recognize this when we've done enough work with sodium chloride. And then we need to set up our conversion factor. We need formula units of NaCl on the bottom, and we need moles of NaCl on the top. And our Avogadro's number from our reference packet tells us that there are 6.022 times 10 to the 23rd particles or formula units in 1 mole of any substance. Now, once we put that into our calculator, we should get 0.415 moles of NaCl. For the next problem, we're actually adding another step. In this problem, we're being asked how many particles of carbon dioxide are in a given mass of carbon dioxide. So if you look at our flow chart, we're starting with our mass of carbon dioxide. We're being asked to find molecules, which are particles. We can't go directly from mass to particles or molecules, so we need to go from mass first to moles using our molar mass, and then we'll go from moles to particles using Avogadro's number. So let's set that up. We have 5.15 grams of carbon dioxide. Again, think nomenclature. This is a covalent compound, carbon dioxide, CO2. And the molar mass of carbon dioxide, add up the total of 1 carbon and 2 oxygens. We're going to put grams of CO2 on the bottom, and we're converting to moles of CO2. And the molar mass of carbon dioxide is 44.01 grams in 1 mole of CO2. So we've used our information to get from mass to moles, and now we need to go from moles to particles. So we need to set up another conversion factor, and we're going to put moles of CO2 on the bottom so that they will cancel, and we're trying to get to particles, so we're going to go to molecules of CO2 on top. And the conversion from moles to particles, a particle in this case is molecules, we're going to use Avogadro's number, which is the number of particles in 1 mole. So Avogadro's number tells us that there are 6.022 times 10 to the 23rd molecules in 1 mole of CO2. When you multiply this out on your calculator, you should get 7.05 times 10 to the 22nd molecules of CO2. For the next problem, we're essentially going in the opposite direction. So we're being given the number of formula units, and we're being asked to find the mass. So we're starting here with our particles, our formula units, and we need to find mass. So in order to do that, we can't go directly through, we have to go through moles. So we're going to start with our formula units, which are our particles. We're going to use Avogadro's number to convert those to moles. So we have 4.00 times 10 to the 22nd formula units of iron 3 oxide. We need to determine our formula of our iron 3 oxide. In order to do that, we can see that it's a metal and a nonmetal, so it's an ionic compound. We need to find the charges and make a neutral compound. The Roman numerals tell us that the iron has a 3+ charge, and oxygen, we know, has a 2- charge. So that gives us a formula of Fe2O3. And in order to go from particles to moles, we need to set up our conversion factor, and we need to use Avogadro's number. So we're going to have formula units of Fe2O3 on the bottom, and we're going to go to moles of Fe2O3. And our reference table has Avogadro's number listed, and it tells us that in 1 mole of Fe2O3, there are 6.022 times 10 to the 23rd formula units. Now we have moles, and we need to convert from moles to mass. In order to do that, we need to use our molar mass. So we're going to have to calculate our molar mass of Fe2O3. We're going to need moles of Fe2O3 on the bottom to cancel, and then we're going to need grams of Fe2O3 on the top. And we need to calculate our molar mass of iron 3 oxide. by adding up the atomic masses of 2 atoms of iron and 3 atoms of oxygen. And when we do that, we get 159.70 grams in 1 mole. Remember that the molar mass is the mass of 1 mole of a substance. And when we calculate that out, you should get 10.6 grams of Fe2O3.